Okay, so this is camera navigation in Rhino, Rhinoceros 3D. Let's start with orbiting. I can use my trackpad, just swiping along it to orbit. I don't know why it jumps like that. Um, but then shift swiping will pan, and then option scroll will actually dolly to your cursor, and command scroll will actually dolly in and out in the center of the screen. Okay, so also if you have a mouse that's or on the trackpad, you could do two-finger click or right-click with the mouse to do orbit, shift, and the same. Okay, there are different projection modes here, so I can choose between parallel, which is like orthographic or isometric, perspective, or two-point perspective, which is actually like a drawing mode where the vertical lines also converge in perspective. They have lens length parameter. I can enter in a specific value. Rotation allows me to tilt the camera. XYZ position in Rhino, Z is up, so I can move the camera up like that. So that gets me to the target. You can see that it actually tried to keep the target location the same. So this is my target. I don't know what exactly it's focused on, but I can say place target, choose this guy's face, and now the center of my rotation is that guy's face. I can place the camera. So let's say place the camera right there. It moved the camera to that position. But probably what you want to do is place the camera and the target. So I can place the camera top of this thing there, and then place the target at this guy's face, and now I'm looking at this guy's face. If I like this view, I can come into this panel, right-click on this label, say Set View, Show Named Views panel. You can see I already did this, Face 2. And now I have this face. You can import and export these things from file to file, which is really nice. You can associate it with a background bitmap, which is just like a background image. So that it'll actually swap out the background image for different views. You can see it's in phase 2. I can rotate. It still says I'm in phase 2 view, but if I go back to name views panel and click on it, it'll go back to the view that I had specified. And if I actually go to perspective, it'll get me into like a default camera orientation, but keep the camera on the target. Okay. Rhino has a quad view, right? So it has all these different viewports. Switching between them up here really is just literally switching my viewport over here. So if I was here and I click top, it actually puts me into that mode, into that viewport. Lens length, rotation, target. Let's go into this menu a little bit more. We have set view. The difference between plan and top. So let's say let's see. Okay, let's say I'm focused on this guy. That's zoom selected. I'm orbiting around him. If I go to top view right now, so set view top, it'll keep my target on that guy. It's essentially the centroid of this guy's body. But if I go to plan, it will put my viewport at the center of the world. That's the difference between top and plan. One associates with your current camera target, and the other kind of resets it to the world origin. They have isometric views, so you can have a parallel perspective, parallel projection from, kind of like 45-degree angles. So the name views panel, have C-plane. So like C-plane, you could do something interesting. So let's say let's make my C-plane to the view, the current view, so that if I orbit now, which I can't do, let's go to perspective and orbit, and you can see that that construction plane, which is what a C-plane is oriented to what my view was. And let's say I kind of want to get back to that, I can go set camera C-plane top, and that'll orient me to the C-plane top, left, right, bottom, right, you can imagine. Place target, we did that. Orient camera to surface. So let's say I click on orient camera to surface. I click on the face of this cube, and now I can kind of choose a point on the cube and my camera is now on that surface, looking in the normal of that surface, which is pretty nice. Let's go back here. Set camera. Is that what I was at? Set camera. Natural paper image. I would imagine this does, like, if you had like a postcard type image in the scene in 3D space, it'll orient your camera to the normal of that image. Show camera. If I click on this, you actually don't see a. It's right that this says top. You actually don't see a camera in your current view because I guess you're it. You are it. It's hard to see the thing that's at your position. But if I look in these other viewports, I can actually kind of see the 3D orientation of my camera, and I can actually use the points to like draw geometry and lines, which can be nice. That's my target there. So now I have kind of like a line in 3D space that exists, and it's just like 3D geometry that I can move or rotate around the scene. Move and rotate, right? So I can really kind of create geometry based on my camera target and frustum. Set camera, rotate camera. This is going to allow me to do like a tripod type movement. If I click and drag in here, you can see it's staying at the same position. If I go set camera tilt view, that'll allow me to actually rotate around if I drag up and down. But no one works like that. If I, let's see, adjust lens length, that'll allow me to change the lens length here. You can see it changing there. But you can see how my object was kind of getting smaller and bigger at the same time. So if I go adjust lens length and dolly, it'll actually try to keep the objects the same size and just change and also change the focal length. You can see all of the position and the lens length changing here, so that you could really get a dramatic effect if you want, without having, because otherwise you'd be going adjust lens length. I want the dramaticness, and then I'll come in and dolly here. And you can see, oh, actually when I put my camera at that position, it's like way too much. So set lens length and dolly is actually pretty useful. Okay, let's go set camera. I'm not really sure what synchronized views does. It doesn't do like zoom selected all, but I guess what it does is it's framing the camera frustum. So I guess it makes sure that this camera's whole frustum is in view in all of these other viewports. So it's like the size of the camera is the same in all of the viewports. And that I think that's it for camera navigation in Rhino.